Hi, in this video, we're going to be working in Chapter 7. In the previous video, we had gone through a simulation and tried to understand the relationship between the mean of a parent population and the mean of the distribution of the sample mean. Also, we talked about variability. So the first thing I want to do in this video is just go into the formula card and ask you as well, please open up your formula card. I just want to show you the formulas and what they look like, because remember, that's always your tool in the tests and quizzes. So we want to make sure the first thing we do when we come to a new problem type is we just put our hands on that. So I'm going to just move over to my formula card for a moment here. And let's see, make it a little bigger. All right, we see here the Chapter 6 formulas at the bottom of the first page. There are two of them. And now let's look at these Chapter 7 formulas. The first one is the mean of X bar is mu sub X bar. And the standard deviation of X bar is sigma sub X bar, sigma over the square root of n. And then there's another one. We'll use that in a moment. But I just wanted to, bring our attention to that. So I have a problem on the whiteboard here. This is a distribution that we've seen and we've played with quite a bit in the class, right? Suppose the distribution of IQ scores has a mean of 100 and a standard deviation of 16. That distribution is something we've looked at before. So that's going to be the parent population. Now, the information about the sample. And a sample of size 4 is taken. So what I'm going to want to do is I want to find think about the distribution of the sample mean. That is, I have 4 randomly chosen individuals and I average their IQ scores. Okay, so we have from the formulas that we just saw on the formula card, mu sub X bar. The mean of the distribution of the sample means is equal to mu, and in this case, that's 100. Sigma sub X bar is equal to sigma over the square root of n, 16 over the square root of 4, 16 over 4. I'm sorry, 16 over 2, or 8. Okay, so what the formulas are leading us to is that the distribution of the mean of the sample of 4 individuals from the IQ of their IQs from the IQ population here, distribution, okay, has a mean of 100. Mu sub X bar is 100 and sigma sub X bar, standard deviation of that distribution of the sample mean, is 8. So I drew some pictures of that over here. The parent population's up here and it has the mean of 100 and the standard deviation of 16. And we see that it looks like this. I just chose the 2 standard deviation interval here just to indicate that result and that the area within the 2 standard deviation interval is 0.9544. According to the empirical rule, it was about 95%, but then we did this example in a previous video, and we determined that more exactly it was 0.9544. Okay, and so this is what that 2 standard deviation interval looks like for the distribution of IQ scores. Now, if we want to think about the distribution of the sample mean, right? So it has a mean of 100 and a standard deviation of 8, right? That was the results we got from here. And what we see is, then this is what the distribution looks like now. The distribution of the sample mean looks like. It has a mean of 100 and its 2 standard deviation interval is between 16 in either direction, 84 and 116. So for the distribution of the sample mean, it's much tighter, much less variability. And 95.44% of the area is snuggled in much more tightly, 84 to 116 rather than 68 to 132. Okay, so I want to talk a little bit about, I made this leap of faith here that I showed you that we had worked with these IQ scores before, right? And I had told you previously that they had a normal distribution. And so I put that there. And then I just drew the distribution of X bar to be have that same normal shape. We saw that in the simulation in the previous video, but I want to go into a little more detail, just showing you how the shapes of the distributions influence the shape, how the shape of the parent population influences the shape of the distribution of the sample mean. So I'm going to come on over here to the notes again. Right. Okay, so coming back to the notes, these are the notes on chapter 7. We looked at these results in the last class. So just moving forward, what this next page here shows us is how the first row are 3 different parent populations. And if we take a sample of size 2, what we have here is the distribution, the shape of the distribution of the sample mean. So let's just start with this first column on the left. This is a normal distribution for the parent population. And what we see is that as the sample size, as we get a random, a sample, we take a sample of size 2, our distribution is still normal, but it becomes a little less variable, right? So the standard deviation is decreasing here. So this is less spread out than that. And then when we go to the sample of size 10, the distribution becomes even more, even more peaked, right? So a smaller standard deviation, but the shape is still, a normal curve. And the same here when we get to 30. So let's look at this other distribution, sort of like a right skew or something like that over here in the middle column. And as we take a sample of size 2, the distribution of the sample mean, it starts to look a little more skewy, right skewed, right? So the tail on the left is softer. And then sample size 10, it becomes a bit looking like a normal distribution, but by the time we get to the sample size of 30, we do see that the distribution of X bar is approximately normal. It's not really exactly normal. We see asymmetries, but it's approximately normal. And this is also the situation over here for this flat uniform parent. When the sample size is 2, we get this triangle. And then as the sample size gets larger, we get this, what we call convergence, a movement to a bell-shaped distribution. Okay, so this kind of, the takeaway is if the parent is normally distributed, then for all values of the sample size, the distribution of X bar is normally distributed. But in the situation where the parent is not normally distributed, as the sample size increases, we become more towards normal. And when the sample size is 30 or greater, the distribution of X bar is said to be approximately normal, even if the parent is not. Okay, and I have this in a tabled form on the next page. So these, like when you read this table, there's information that's given. So different possible problem types, if you want to think about it. So if the parent population is normal, you would be in this row. If the parent population is not normal, you would be in one of these two rows. Okay, and then there's a mean and a standard deviation and the sample size. So these are all pieces of information you should garner from reading the problem. So for normal distribution, all sample sizes, the distribution of the sample mean is normal, and it has the mean and standard deviation, which was determined in the previous video. And also we looked at that on the formula cards this today. And if the distribution of the parent distribution is not normal, then we have two different situations, right? So when the sample size is small, we can't really say what the distribution of the sample mean, what that shape is going to look like, right? And that's to say, when we're up here, we can't really say it's normal, right? We're in the process of getting there, but we're not there. So that's the second row. And then the third row is the situation where the sample size is large, greater than or equal to 30. And then the distribution of the sample mean is approximately normal. Okay. So here is a problem that actually we just kind of had on the board a moment ago. So we're going to go back over to the board over there. And the question says, suppose that the distribution of IQ scores is normally distributed with a mean of 100 and a standard deviation of 16, and sample of size 4 is taken. Find the sampling distribution of X bar. That's another way of saying find the distribution of the sample mean. And we're going to try to fill in this table here. So we see that the parent distribution is normal, and with a mean of 100 and a standard deviation of 16, and the sample size is 4. Okay. So in order to be able to determine the distribution of the sample mean, we need to figure out what row in the table we're in. That's one way to think about it. There's other ways to think about it. But we can see here we're in the first row. So because we're in the first row, right, because the parent population is normal for all values of the sample size, the shape of the distribution is normal. And then we could, we fill in here that the mean is 100 and the standard deviation we determined was 16 over the square root of 4 or 8. Okay. Just because the video is getting long, I'm going to break it here and we're going to wrap up. Now that we've determined the distribution of X bar, we'll move ahead in a moment and do a probability calculation.